Greetings from Microlab Northwest. I thought we would just briefly go over a couple of the two microscopes that are very common in analytical labs. One of them is the BH2 from Olympus. The other is the Labophot Pole from Nikon. Each of these is a polarized light microscope. It has the polarization attachments that allow you to do optical crystallography. Some of that we'll get into in a bit later. But I thought we'd start out just naming some basic parts. Although it might seem very obvious, these are called the base of the microscope. The base of the microscope extends to the the back of the microscope. And then the cross piece here is referred to as the arm of the microscope. Above that, we have the head of the microscope. Now, in the base of the microscope, we have the illumination systems. So our bulbs or the LEDs that provide our illumination are in the base. The light comes through the base and into the exit lens out of the base. At the exit lens out of the base, we have an iris. That iris is called the field iris. Now, the field iris needs to be focused around any particle that we might be looking at on the stage of the microscope. In order to adjust the field iris, on the Olympus, we have this little ring that rotates. That changes the size of the field iris. On the Nikon, it's a little wheel right here behind the exit lens that's in the base. In order to focus the image of the field iris around a particle that's in focus on the stage of the microscope, we need to use the substage condenser focus knob. Now, those are always on the left side of the substage carriage. And here you can see we're moving on the Nikon. This knob adjusts the position of the substage condenser, and that will bring the image of the field iris into focus. It's in the same position here on the Olympus microscope. In order to center the image of the field iris, we need to use the centering pins. The centering pins for the Olympus are two pins that extend out of the carriage base in this position here. On the Nikon, there are pins right here on each side of the carriage that allows us to center the image of the field iris. Above the centering pins, we have the condenser itself. The condenser has a rotating turret. On both scopes, the rotating turret is basically the same position, same function. It rotates in different stops for controlling the illumination system coming through the microscope. Above the substage condensers, we have the stage. And the stage for a polarizing light microscope is rotatable, and you can actually measure angles if need be using the stage. Above the stage, we have the nose piece. The nose piece is the part of the microscope that holds the objectives. Each of these objectives is centerable to the optic axis of the microscope. Using these little pins. In each case, you can see these little pins in the nose piece that allow us to center the objective to the optic axis of the scope. Above the nose piece and attached to the arm, we have the polarizing intermediate tube. The polarizing intermediate tube here on the Olympus is this tube right here, and on the Nikon, this smaller tube here. It contains the analyzer, which is the second polarizing filter on a polarized light microscope. It also contains a compensator slot. These little compensators are special attachments for characterizing the properties of a crystal or for creating a special illumination process, a special illumination condition that we'll talk about later. Above the polarizing intermediate tube, we have the head. This is a trinocular head. It contains the two oculars, or the two eyepieces, for us to look through, and a third path that takes the image to the camera so that we can record what we're seeing. That is basically the parts of the scope that we're going to be talking about more later as we get into setting up Kohler illumination and all of the other illumination systems that we need in order to look at particles and to characterize them that are collected in any kind of environment. So for now, that's enough. We'll see you next time. Thank you.